Well, thank you for joining me on exercise 2A. The last question of this exercise is question 13. Use the ability of your calculator to differentiate, to determine, and see if you can obtain the same factorized answer using the product rule and chain rule without the assistance of your calculator. Well, I'm just going to go straight to use without the calculator because you can try that on your calculator. And we've got two products, U and V, where U is x minus 3 cubed and V is 3x plus 7. U dash is 3 times that bracket to the power of 2, and the derivative of the bracket is simply 1. V dash is simply 3. So the product rule says y dash is u v dash plus vu dash. So it's u x minus 3 cubed times v dash, which is 3, and then v, which is 3x plus 7, and then u dash, which is 3x minus 3 squared. Now let's take common factors, which is 3. There's an x minus 3 in both, and the most common is 2, and that's all that's common. So let's take 3 out. We've done that. We've got one of these factors left, and we've got, in the second term, we've got a 3x plus 7. We can add our square brackets here to be 4x and minus 3 plus 7x plus 4. We can take 4 out. 3 times 4 is 12. And we've got an x plus 1, but we've removed the 4 here. And then we have the derivative, and that's using the chain rule and the product rule. Now we want the stationary points. The stationary points is when dy dx y dash equals 0. So we let our derivative, x minus 3 squared, x plus 1 equals 0. Therefore, x minus 3 is 0. So x could equal 3, or x could equal negative 1. Now we want the coordinates. So when x is, say, negative 1, substitute that into our y value. So negative 1, take 3 cubed, and 3 times negative 1 plus 7. So it's negative 4 cubed, which is 4 4s are 16, 4s are 64. And negative 3 plus 7 is 4. So we've got negative 256. So that's the coordinate, negative 1, negative 256. When x is 3, y is equal to 3, take away 3 cubed, and we've got no 3 3s plus 7, we've got a 0 value. Therefore that's a 3, 0. And then it said, determine the coordinates of the curve, use the sign test or the second derivative. Well, let's just use the second derivative, shall we? Okay, so the first derivative is y dash is 12 x minus 3 squared. Well, and x plus 1, where u is, say, let's just say x minus 3 squared, and v is 12 x plus 1. U dash is 2 x minus 3, and v dash is simply 12x. Therefore, the second derivative will be uv dash plus vu dash. So it's x minus 3 squared times v dash, 12. And v is 12 x plus 1 times u dash, which is 2 x minus 3. So we've got common is 12, x minus 3 is common, and what's left? We've got another x minus 3 from the first term. We've already got the 12. We haven't got the 2. We haven't got the x plus 1. And we've got the x minus 3. So we've got 12, x minus 3, and 3x minus 3 plus 2 minus 1. So substitute when x is negative 1, y dash will be 12, negative 1 minus 3. 3 times negative 1 is negative 3. Take away 1. So we've got a negative 4. We've got a negative 4. We've got a 12. That's a positive number. Therefore, it's concave up. So it's a minimum. When x equals 3, y dash will be 12. 3 minus 3. And 3 3s are 9, minus 1 is 8, which is 0. Therefore, it could be a point of horizontal inflection. Let's see if that fits. So we've got a power of 4, because x cubed times x1. We've got a power of 4, so it's possible we could have up to 3 turning points, but there's only 2, so one of them has to be a point of inflection. We'll be asked to sketch it. Determine? No. That's all we were asked to do. Okay, I hope this has helped. Until next time, stay happy.